Hello guys, welcome back to my channel, Memo African Motives. In this platform we shall be focusing actually on the question paper which was written in March 2018 for Mathematics N2. So we shall be focusing on the question paper, guys, which was actually written in March 2018, which is an X paper, and this is actually from 9 to 12, as you can see. And so we shall actually try by all means to quickly work on the questions, trying to work on them separately so that we can understand how we're supposed to answer these questions. So let us quickly rush through the first questions and so forth. So given the instructions and so forth about the instructions and the information that you're supposed to use in exam there. All right, then now let's quickly rush through the first question where we're asked to simplify each of the following expressions using exponential laws. The use of a calculator is restricted. Show all steps. So take note, guys, in this case, the use of a calculator is restricted, which means we do not need this, and you're supposed to show all the steps which are required in this paper to answer these questions. Okay, so let us quickly rush through these questions, guys. We are given the first question, which is that is 1.11 there. We have given 32 to the exponent of 3 over 5 multiplied by 81 to the exponent of minus 3 over 4. Then this is 2 and 1 over 4 to the exponent of minus 3 over 2, like this. Okay, so the idea in this case is trying to simplify and trying not to use a calculator, because the condition is asking you not to use a calculator. So what are we going to do in this case? Okay, we know that there's a relationship that we have between these numbers. We've got 5, 4 here. 32 is the same or can be written in the same manner as 2 to the exponent of 5. So now, because there's an exponent of 3 over 5, which means you're going to multiply by the exponent of 3 over 5. Okay, so this is going to be to the exponent of 3 over 5. So this is what you're going to have. This is 3 over 5 multiply by 81. It can be raised to the exponent of 4 because this is 3 to the exponent of 4. So you can just cross-check using your calculator, but you see that it's 3 to the exponent of 4, which is to be multiplied to the exponent of minus 3 over 4. Over in this case, we have got 2 and 1 over 4. This is actually a mixed fraction, so you have to rewrite this fraction as an improper fraction, which is going to give us 9 over 4. All right, so as you can see, guys, this is 2 and 1 over 4 from your calculator, or you can just multiply then add. So if you multiply, it's 4 times 2, which is 8, plus 1, which is 9 over 4. In terms of exponent, this 9 over 4, it can be written in terms of 2 here, which is 3 over 2 here, because we want to write to the exponent of 2, so you can write it as 3 over 2. That's in its simplest form, to the exponent of 2. So as you can see, we are writing these numbers in terms of their simplest form. So 9 over 4 can be written as 3 over 2 to the exponent of 2. So if it is 3 over 2 like this to the exponent of 2, but already there's an exponent which is there of minus 3 over 2, so you're going to multiply to minus 3 over 2 because there's an exponent which is already outside there. All right, now let's simplify, guys. We know our laws of exponents. When there's an exponent and exponent, you multiply. So that's gonna be 5 times 3 over 5. As you can see, that's a 3. So you're going to be left with 3. So that's 2 to the exponent of 3 times 3 to the exponent of, you do the same, that's 4 times minus 3 over 4 from this part, which is going to be minus 3. So it's going to be 3 to the exponent of minus 3 over this part. We've got 3 over 2. That's 3 over 2 to the exponent of, you multiply, that's 2 times minus 3 over 2, which is going to be minus 3. All right, something like that. But how can we work around with this type of an expression from this part? How can we simplify this further? Because here there's nothing that we can do on top here. Let me just write it. 2 to the exponent of 3 multiply by 3 to the exponent of minus 3. There's nothing much I can do there. There's nothing I can do. But I want us to see something here. If I am writing this as dividing by 2, or like what we can see here, that is a 3 over 2, and we are dividing. There are so many ways that we can actually simplify this part alone. 1 over a certain number, like 1 over xy, like this, can be written as y over x. Just invert the second fraction. So which means we can also do the same in this case, because as you can see, we are dividing. This is like we are dividing. So the moment you are going to multiply, now we are going to invert. Or you can multiply this by minus 3 inside. I want you to see something. So this can be over, if you use this, it's going to be to the exponent of minus 3, because this is same as 1, this is same as 1. So exponent versus exponent. So it will be 3 to the exponent of minus 3, like this, which is dividing 2 to the exponent of minus 3, like this, 2 to the exponent of minus 3. But this is from one thing. So that is where now I was talking about this idea of saying if you are dividing, you can now multiply. So I think now you can see it clearly when it is written like this. So you're going to have 2 to the exponent of 3 times 3 to the exponent of minus 3 times the moment you multiply, which means you're going to invert this. Or you can just write this as positive exponents, which is one other way, because it's given as over. So it's going to be 3 to the exponent of 3 times over this one, 2 to the exponent of 3 again. And this one is going to be minus 3. Okay guys, let's just do the normal thing. Multiply by 2 to the exponent of minus 3 over 3 to the exponent of minus 3. So this one is going to carry a negative, but this one is going to carry a positive because it's on top. So it's going to remain with a negative. This one is on the bottom. So the moment you write it on top, it's going to have a positive exponent. Okay, I hope it's clear now. Now, starting with 2, you can multiply this. Take note, you are multiplying now. These exponents, we are going to add them because the bases are the same. So we are going to add 2, 3 and minus 3, guys. If you add this one, it's going to give us a 0 there. That's 2 to the exponent of 3 plus minus 3, like this. So that one is going to give us a 0, which is the same thing with 3 to the exponent of minus 3 plus 3, because we are adding to 3. Minus 3 plus 3, that's a 0. So you're going to multiply to 3 to the exponent of 0, like this. All right. 2 to the exponent of 0, that's 1, times 3 to the exponent of 0, that's 1. So if you multiply, you are going to obtain a 1 in this case. So that's how they can ask these questions. That's how they can ask these questions. So it's a matter of playing around the question and understanding the concept that you're given. What are you given actually? What can you do with the information that you're given? How can you put together that information? So another question now, we are given to simplify again using the same concept of applying the exponents, but we have got something there which is pretty different from what we are given from this question. Let's just see what we have there. We have got 2 to the exponent of n plus 4 minus 6 by 2 to the exponent of n plus 1. Okay, then we have got a 2 to the exponent of n plus 2, which is being multiplied to 5. All right. So each and every stage should be of warning on how you simplify or how you evaluate that stage. All right. If you are to cross-check, guys, I want you to note something here. Actually, all right. I was looking for this thing here. Let me put it this way. All right. I want you to note something here. Whenever you are given a condition where you are subtracting or adding, there's nothing that you can do, but you can try by all means to factor out whenever it's possible. Like, let me just write it this way. 2 to the exponent of x plus y like this, which is added or subtracted to 2 to the exponent of x plus m like this. As you can see, we've got x here, we've got x here. You can factor out 2 to the exponent of x and remain with 2 to the exponent of y minus 2 to the exponent of m. So this is the concept that you can use there. All right. Take note what is happening, guys. If you factor out this x, 2 to the exponent of x, you're going to be remain to the exponent of y. If you factor out x, you're going to be remaining to the exponent of m. So let's try and do that and see if it is possible for us to factor out. All right. Because here we are subtracting. All right, so 2 to the exponent of n, 2 to the exponent, just like x and x. So we've got 2 to the exponent of n into 2 to the exponent of y, which is this 4 now. So you're going to be left with 4. So it's 2 to the exponent of 4 minus 6 by 2 to the exponent of 1, which is same as what? 2 to the exponent of 1, which is same as 2. All right. Let's move on and see what we have here. On this part, there's nothing that is common. There's nothing that is common here. We are multiplying, but from our laws of exponents, we know what made you to multiply these, to add these two, is because you were multiplying 2 to the exponent of x by 2 to the exponent of 2. That is why you ended up adding the exponents. So if this is the case that was there, so which means we can separate this as 2 to the exponent of n times 2 to the exponent of 2, just like this part, times 5, which is same. So this one is same times 5 to the exponent of 1. 5 is same as 5, like that. All right. Something is interesting from this part, because these two are the same, and here there's a bracket, which means we are multiplying here. So these two can cancel now because of multiplication, but these cannot cancel. So which means you're going to simplify 2 to the exponent of 4, which is going to be 2 times 2 times 2, 4, 2 times 2 times 2 times 2. Remember, no calculators, which is going to give us a 16. That's 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. So you're going to be left with 16 minus 6 times 2, because 2 to the exponent of 1 is same as 2. So 6 times 2, that's 12, over 2 to the exponent of 2 times 5. So 2 to the exponent of 2, that is 4 times 5. 2 to the exponent of 2, that's 2 times 2, which is 4 times 5. Okay, so you're going to be left with 16 minus 12, which is 4, over 4 times 5, which is 20. So I can reduce this by 4. 4 into 4, that's 1, which is 5. So I'm going to be left with 1 over 5 in its simplest form. So that is that was the condition there, because we are told not to use a calculator. So you're supposed to try by all means not to do that and apply the stages as in a proper way. So in this case, we're going to obtain a 1 over 5. Just imagine, guys, with all these calculations, and the answer is just 1 over 5 like that. But that's how they ask these questions actually, so you must be used to it. Given log 2, given 2 is equal to 10 to the exponent of a, 9, 10 to the exponent of b, determine the values of log 4 and log 6. All right, an interesting question. Let's see what you're given. 2, that is on 1.2. 2 is equal to 10 to the exponent of a, 9 is equal to 10 to the exponent of b. All right. We want to find the value of log 4. Where can we find the value of log 4? This is the question, guys. Okay, this is what you're going to do. Because here we are given exponents, because this is an index form or an exponential form. Let's try and rewrite this in log form. Okay, remember from our log form I talked about this, that the log of a number, which is log 2, and the base, which is base of 10, is equal to the exponent, which is a, from exponential form to log form. If the base is not given like this, it means you are in base 10. So this one can be log 2 base 10, or it can be just be log 2 like this. Base 10, you can choose to write base 10, or you can choose not to write the base. All right. So the question is, how can I separate this log 4 to write it in terms of log 2? How can I rewrite this in terms of log 2? Okay, this is the case. If you expand this number 4, you're going to obtain 2 times 2, if you're not mistaken there. 2 times 2, which is the same thing. We have two options here, 2 times 2, or it can be like this, log 2 squared. It's one and the same thing. So if you use this concept, therefore, you're going to ask yourself that, what is the condition that made you to multiply these two numbers? What was the previous stage which made you to multiply? Remember, you can only multiply these numbers if the logarithms were adding to each other. So which means this 2 times 2 is from log 2 plus log 2. That is where we obtained a stage like this. So we can substitute now log 2, because our answer is needed in terms of a. So log 2 is there in terms of a, which is our log 2, it's a, plus log 2 is there in terms of a, which is a. So a plus a is just the same as 1a plus 1a, which is 2a. So therefore, this is what you're going to obtain for log 4. Log 4 is going to be equal to 2a. All right. Let's say you used this concept here of writing it as log 2 to the exponent of 2. What are you going to do? You're going to apply the laws of logarithms. Remember, whenever there's an exponent, you can drop this exponent, or you can multiply by the exponent to the log, which is 2 log 2. So that was what you're going to do, which is 2 times log 2 is there in terms of 2. Log 2 in terms of a. Log 2 in terms of a is a. So it's 2 times a, and 2 times a is 2a. So as you can see, we're obtaining the same thing here. So that was the option for log 4. Let's see log 6, which is on 1.12. We need to find log 6. So what are the possibilities of obtaining log 6? Okay, log 6, if we expand this 6, you'll see that we have got something like log 2 times 3. If you multiply these two numbers, you're going to obtain 6. Okay, now just like what we did here, you're multiplying. What made you to multiply these numbers? It's because you're adding the logarithms, which are of the same base. So you're going to add log 2 this time to log 3. Log 2 is there because we are given the value of log 2 is a, so it's going to be a plus, but where is the value of log 3? Log 3 is not given, but I have something that has to do with the 3 here, because there's something that has to do with 3 because there's 9 here. So taking the same concept that we did here, what are you going to have from 9? Okay, let's work out for 9. 9 is equal to 10 to the exponent of b. All right. So you're going to have log of the number, which is log 9, in base of 10, which is equal to b. But remember what I told you guys, that 10 does not matter. So it's log 9 is equal to b. All right. But we don't need log 9. We need log 3, not log 9. So what am I going to do? Okay, I'm going to write this 9 in terms of 3. I know that 9 in terms of 3 is 3 to the exponent of 2. Okay, 3 to the exponent, that's 3 times 3 to the 3 to the exponent of 2. And from the laws of logarithms, I can drop this exponent, which is 2, to be written as 2 log 3, which is equal to b. So remember what I want to calculate, guys. I want to obtain log 3. So what can I do now? I can divide by 2. I can divide by 2. So that means log 3 was going to be written as b over 2, like this. So if this is the value of log 3, this is the one that I'm going to substitute here, because remember, you wanted to calculate the value of log 3, and we have obtained the value of log 3, which is b over a. So it's going to be b over 2, not b over a, but b over 2. So this is what is going to be the value of log 6. So log 6 is going to be a plus b over 2, like that. So guys, just look at the conditions. So these were the conditions actually that you had. You're supposed to at least simplify your questions in a better way before attempting anything. Then you use the information from the part that you're having to expand further. All right, so let's see another question, which is 1.3. we're asked to solve for x. So take note, to solve, guys, is to find the value of x. When you're asked to solve for x, you are finding the value of x. So take note, guys, about the marks that you're given there. 3 marks. There's a lot of marks, and the other one is 4 marks. So anyways, let's see how we're supposed to solve this. So the first part we are given 1.31, which is 9 to the exponent of x, which is equal to 1 over 3 square root of 3, like this. All right. Here there are 2 things which are actually happening that we need to get rid of. Okay, the first thing is let me just separate this so that I can explain. All right, we have something that has to do with 3 here. Guys, take note, we've got 3 here, we've got 3 here, 9. What can we do with this 9 so that we can write it at least in terms of 3? Okay, we know that 3 to the exponent of 2 is actually a 9. So it means in place of 9, I can write this in terms of what? In terms of 3. So it's going to be 3 to the exponent of 2 times x. So it's supposed to be times x. So if multiplied to x, it's going to be 2x. Okay, which is equal to, you've got 1 over 3. From our laws of exponents, we know that 1 over 3 same as 3 to the exponent of a negative 1. Okay, times square root of 3. Where are we going to have this square root of 3 from? Square root of 3 is same as 3 to the exponent of a half. Take note, guys, square root of x, x to the exponent of a half. So now we can rewrite this 3 to the exponent of 2x, which is equal to, here I'm supposed to combine. I'm multiplying, so I'm back to that condition now of adding the exponents. So it's going to be minus 1 plus a half. Okay, this is 3, not x. This is 3, guys. Take note, this is 3. So it's 3 to the exponent of minus 1 plus a half, because the bases are the same. So we have to add the exponents, which is going to give us minus a half there. If we are not mistaken, guys, we're going to obtain a minus half from your calculator there. Minus 1 plus a half, which is minus half. Then that's what you're going to write here. 3 to the exponent of minus half. So what's interesting, or what we going to benefit from this? Remember, I told you guys that when the bases are the same, when the bases are the same like this, you are equating the bases which are the same. It means the exponents are the same. So therefore, a is equal to b. Also, the exponents are the same. From the concept that the bases are the same, it's a default thing. So that means I can cancel this and this because I want to equate the exponents. So I'm going to equate this part here, 2x to minus half. All right, so take note, guys, of the part that we are talking about. I'm just gonna do this so maybe it's gonna be clear. I'm talking about this part to this part here. Yeah, something like that. So what are you going to have at the end in this case? Because we want to find the value of x, and as you can see, we are multiplying. So we are going to divide by 2 so that we can be left with x. So minus half divided by 2, that's minus 1 over 4. Use your calculator properly, guys. Do not rush when you are in exam or you're writing a test. Don't rush. Make sure you apply your calculator properly. Yes, just because there's too much light here, but I'm just gonna see okay, maybe this part here, yeah, something like that. Just put it like this, minus half, okay, minus half like this, then over again, over 2 like that. You're gonna obtain no, this, the minus half is on top. Oh, the minus half is on top, so let's just put a bracket there. Let's put a bracket like this. Okay, like this, minus half on top in a bracket. Okay, then you close it, then you divide by 2 like this. Now it makes sense. All right, so you're going to obtain something like that. So that is what you're supposed to do there. Make sure, guys, how you use your calculator there in exam is going to be very, very important. Okay, anyways, that's what we had from this question of solving. Let's see the other part also on solving. Given a log, and you've got 4 marks for this logarithm that you're given, which is on 1.32. Okay, so you're given log x plus 3, that's in base 5, minus log 2x plus 1 again, which is in base 5 again. Okay, so this is equivalent to 1 minus log 9 base 5. Okay, so there are actually many ways of simplifying this. I can't say we are limited to one thing or something like that. No, there are so many ways that you can actually do this. Okay, we here on the left hand side, we are given what is on the left hand side here. These two are in the same base. This is the same base, guys, take note. And we are subtracting logarithms, and we know that when you are subtracting logarithms in the same basis, you're going to subtract the numbers. Let me just write log a minus log b is going to give us what? Log a over b, provided that the base is the same. So we've got the base, which is the same. So in this case, the base is 5. So that's what you're gonna do. So let us quickly have this. It's going to be like log x plus 3 over, you divide to 2x plus 1 like this. All right, which base are you in? You are in base 5, which is equal to 1. Take note, guys, 1 in terms of log is log a base a, which gives us a 1. Okay, so we are in base 5, we are in base 5, we are in base 5. So already the base is there, so which means log of base 5 definitely supposed to be log 5, because the base and the number should be equal. So already I have the base, so the number is definitely a 5, which is going to give me a 1. So that means this 1 here is representing log 5 base 5, because you are in base 5. Okay, but it's going to subtract log 9 base 5. So this is the case. So you're now back to the same thing. You are subtracting logarithms, you're going to divide the numbers. So it's going to be 5 over 9 like this in base 5. This is what you're going to have. So you're going to have log 5 over 9, which is in base 5. I hope, guys, you understand this part of 1 that I took here. All right, now on this condition, what am I going to do? Okay, we know that whenever the logarithms are equated and are the same like this, logarithm of a is equal to the logarithm of b. When these two are equal, the bases are the same like this, you can actually cancel this to say A is equal to B. Okay, that's what you can do in an easier way. So in this case, that's what we have. So you can actually cancel this to say this log base 5, this log base 5 here can cancel. Yeah, log base 5 and log base 5 can cancel. That means you're just going to be left with x plus 3 over 2x plus 1 like this, which is equal to 5 over 9. So which is now an advantage because I can cross multiply now. So that's 9 times this part here. So you can open a bracket or you can just multiply 9 times x. Make sure you multiply every term. 9 times x, that's 9x. 9 times 3, that's 27, which is equal to, you do the same, 5 multiplies everything. So it's 5 times 2x, which is 10x. 5 times 1, which is 5. You multiply every term. All right. Now collect like terms. So this is the smaller number, so I can take it to the bigger number here, which is going to be 10x. If I take 9x to this side, it's going to be minus 9x. 5 to this side is going to be a minus, so it's going to be 27 minus 5. So definitely I'm going to be left with 22, which is equal to x. Just like that, x is equal to 22, guys. Is there anything that we can do? There's nothing. There's nothing, guys. So therefore x is equal to 22. We are done. So as you can see, sometimes you'll be surprised, I've already reached the answer there, something like that. But it must not be of surprise in exam. It must be something that you're supposed to see where you are going and where are you going to opt, which part is going to give you the exact thing or the exact answer there. All right, but that's what we had, guys, on this logarithms part, the logarithm part. So let's see another question. What we are given here, we are also now is given b is equal to, we are asked to make q the subject of the formula. All right, so this one is now easier to work on. It's now easier, guys, to work on. This is 1.4. We are given that b is equivalent to the square root of, that's 3pr over 2 pi q. That's 2 pi q, guys, like this. Okay, so the question is make q the subject of the formula. Okay, so we have to make q to be the subject of the formula. Okay, so guys, don't mind these thoughts. Okay, so what are we going to do? We have the first thing, which is because the q that we need here is actually hidden inside the square root. So it's inside the square root, so there's no way we have to remove the square root. So how do you remove the square root? You have to square both sides. So it's squaring. So you square both sides. All right, so let's square both sides, which means we are going to have this to the exponent of 2, this to the exponent of 2. So you're going to have b squared, which is equal to, remember, you are putting the square to remove the square root. The concept is to remove the square root. So which means the square root is no longer there the moment you square. So you're going to be left with 3pr over 2 pi q like this. And make sure that you have to write like this part as it is, the capital letters as they are, the small letters as they are. Okay, so here we can now clear fractions, because as you can see, we're given a fraction. So I can clear the fractions here by cross multiplying. Yes, I can just cross multiply this to this. Okay, so that means we are going to be left with 2 pi q times b is going to be 2 pi q b squared. All right, which is equal to 1 times 3pr. It's going to be 3pr like this, because you're multiplying by 1. Remember, what you need is to make q the subject. And the q that you are given is being multiplied by, it's multiplied by 2 by pi by b squared. So how do I remove this pi that is multiplying? I have to divide by 2 pi b squared. The pi that is multiplying, I divide by 2 pi b squared, the pi that is multiplying. So this and this can cancel, pi and pi can cancel, b squared and b squared can cancel. So that means therefore q is equal to this part now on the left hand side, which is 3 pr over 2 pi b squared. So that's what you're going to remain with at the end. So guys, that's how they ask these questions. If you are to cross check on these typical questions, that's how they ask these questions, and you're supposed to be very, very careful the way you approach the question, or the way you are going to attempt the question that you're given. So anyways, from that part now we're asked, hence calculate the value of q. We now need to find the value of q. If b is equal to 11, r is equal to 16, and p is equivalent to 12, what is going to be the value of q? So actually this is a continuation part. This is 1.41 like this, okay, and this is 1.42. Okay, so like I said guys, this one is just a continuation because already q is there, so you're just going to write q is equal to that's 3pr, so it's 3 times the value of p. All right, let's go back here. Let's go back here, guys. What is our value of p here? This is 12 here, so it's going to be times 12 times r, which is 16. Our r in this case is 16. Okay, over, we are substituting 2 pi b squared now, so it's 2 pi b squared like that. So it's, which is 2 times pi times b squared. What is the value of b? We have to substitute the b, which is 11. Our b in this case, which is 11, so you're going to substitute 11, but there's a squared there. Okay, so this one I want you to give me the answer there, guys. I want you to work on it and obtain the answer. So you're supposed to obtain something like this, 0.758. So just try and simplify this, guys. I trust that you can do this. You can obtain this one. So you just have to use your calculator properly on attempting these typical questions. So as you can see, guys, that's how they ask these questions and how you're supposed to attempt the question. So it's very, very important. And as you can see, this is the first question, a total of 24 marks. So sometimes you are not supposed to lose these marks, guys, especially on the first question. So what is important to understand this part of change of subject or formula. It's very, very important, and also working with logarithms is also very, very important. So that's it, guys, for Mason African Motives, working on question papers and revision. So we shall meet again as we shall be revising more questions and working with more question papers, so that at least we can be able to prepare ourselves for the exams which are ahead of time. So that's it, guys, till we meet again.